Dear student, today we are going to learn about the various geometry of a coordination complexes in the light of VBT. In the last video, I have told you about the various postulates of VBT, and there are some rules. By following those rules, you can easily understand or explain the geometry and nature of magnetic property of a given complex compound. Now we shall try to solve the various example. The first example we shall take, that is from octahedral complexes. Now we shall take the example that is a CO NH3 by 6 tripositive is a low spin complex. Low spin complex I have told you in the last video, that is it is utilizing the n-1 d orbital. Remember this. Now in this, first we have to find the oxidation state of a central metal ion. Now here in this complex ligand is neutral. That's why the net charge which is present on this complex is the oxidation state of that central metal ion. That's why its oxidation state is +3. Now the electronic configuration will be here. Now the electronic configuration will be as follows. Since cobalt have an atomic number of cobalt, that is a 27, in general we can write its electronic configuration with reference to argon, that is Ar18 4s2 3d7. We can write this electronic configuration. Now we have to consider this electronic configuration right now. We can write this as that is 3d 4s and 4p. D have a 5 suborbital. That's why we can write here S have 1 and P have 3 subatomic orbital, like this. So we can write electronic configuration by distributing these electron, and that is 4s2 3d7. Now we can write this as 2 electrons are present in 4s level. There are 7 electrons in 3d level. So first we shall, following the Hund's rule, first, second, third, fourth, fifth, and next pairing will be start. First, second, third, fourth, fifth, sixth, and 7 electrons are there. Now the oxidation state of cobalt is +3, means it is losing the 3 electron for the formation of such complex. That's why we shall remove 3 electron from this. That's why its configuration will be now 2 electron from 4s level and 1 electron from 3d level. Okay, so there are 1 pair of electron and 4 single electron. Now the third thing you have to keep in mind, you have to count the number of ligand in the complex, and you have to provide such a vacant orbital of the cobalt. Now the number of ligand are 6, that's why we need 6 vacant orbital, 3 from 4p and 1 from 4s. There are 4 vacant orbital, and two, since it is a low spin complex, so we require two orbital from 3D level. So we can transfer this electron, or electron will get, this electron will jump from this level to this level, and this electron will jump from this level, means pairing of the electron will be takes place. After the pairing, its configuration will become these two electrons are already present here. Single electron is present, this electron will shift in this level, then it will also become a paired, and this electron will jump to this level, it will also a paired, means there are 6 ligands, so we require 6 vacant orbitals, first, second, third, fourth, fifth and sixth. All these orbitals take part in a hybridization. Now their electron geometry will be like this. Type of hybridization will be, there are two d orbital are taking part, that's why we can write here d2, 1 s are, that's why s, and 3p are taking part, that's why type of hybridization will be d2sp3. so in this way we can form the type of hybridization. Now we have to write the whole of the now the electronic configuration after the formation of whole of the complex will be written as follows. That is a 3D, this one is a 4s, that is a 4p. All electrons are paired already here. Now the remaining electrons are there. Vacant orbital first, second, this one is the third, fourth. These are the electrons which are given or donated by the ligand to the central metal ion here from, which is shown by the arrow, that is the d2sp3 type of hybridization. And its geometry will be like now, it is CO in the center, it is first NH3, second NH3, this one is the third one, or you can write here, that is a NH3, fourth NH3, this one is the fifth one, and here that is the sixth NH3. Okay. Now in this complex all the electrons are paired, there is no unpaired electron, that's why this one is a diamagnetic in nature. This complex is a diamagnetic in nature. What is the magnetic property of this? It is a diamagnetic in nature. Okay, so you can write this in this way. So that is the formation of a complex in which we can write the magnetic property of a given complex, that is diamagnetic in nature, and second, what is its geometry, that is the octahedral geometry, and type of hybridization, that is d2 sp3. So in this way we can draw the structure or write the types of hybridization and geometry, and also we can explain the magnetic property of a given complex. Another example you can take, that is COF6. What is a COF6 trinegative? Is a high spin complex. This is a high spin complex, means it is utilizing the outer orbital now, that is 4p and 4d. Okay, so you have to follow the same procedure. First you have to pick out the oxidation state of this complex. Here fluorine carry a 1 minus charge, that's why 6 fluorine are there, so minus 1 into 6 will be equal to minus 6. Net charge is minus 3, that's why you can write here plus 3, means the oxidation state of cobalt is plus 3. You can directly calculate the oxidation state by the another method, but it is the short method through which you can calculate the oxidation state of a given complex. Now cobalt having a atomic number 27, if you write the electronic configuration that with respect to argon, then Ar18 4s2 3d7. Now it's a electron configuration in valence shell, that is CO in tripositive state, where that's why we can represent the orbital picture here, that is 3d 4s, and this one is the 4p. Now there are 2 electrons in 4s level, that's why we can write 4s in 3d. 7 electrons are there, first, second, third, fourth, fifth, sixth, and this one is the 7 electron. After removing the 3 electron, because CO in a tripositive in this complex, that's why it is losing 3 electron, that's why we can remove 3 electron from this orbital picture. That's why 2 electron from 4s level and 1 electron from 3d level. So after this its electron configuration will be right now. Now since it is utilizing it is the high spin complex, that's why no need to transfer this electron or pair this electron in this orbital, because it is utilizing the outer orbital. So we need to provide the 6 orbital for the formation of such a complex. So we can write here, that is 4s, that is the 4d. D have a 5 orbital, first, second, third, fourth, and this one is the fifth one. So first, second, third, fourth, fifth, and sixth. So we need 6 orbital here, like this. S, 1s, that 3p orbital, and D2. 3 plus 2 plus 1, that is 6, because there are 6 ligands. So type of hybridization will be sp3 D2, and the geometry of this complex will be octahedral, like this. All the fluorine will be surrounded to the cobalt, like this. And its paramagnetic nature is its magnetic property is paramagnetic in nature. Why paramagnetic in nature? Because there are 4 unpaired electrons are there in this complex. There is a 4 electrons are unpaired, that's why it is paramagnetic in nature. So in this way you can draw the structure of a particular given complex. Okay, hope you get the lecture. Now the remaining we shall discuss in the next video.